Good morning and welcome to our lesson today. Today we're studying lesson 8.7. We are going to talk about factoring special products. So we're going to factor the difference of two squares and also factor perfect square trinomials. I want to go on record as saying the most important part of any time you factor something is you always must ask this question. So if you're taking notes, it would be great if you would write it down, highlight it, and star it. But each and every time you need to ask yourself, is there a greatest common factor? If there is a greatest common factor, I don't care how long, how big, how fat, how ugly your polynomial is, you must always take the greatest common factor out first. And the reason being is this: what's left inside the parentheses might fit a very nice, easy pattern and make your life extremely simple. So we're going to look and we're going to start off with factoring the difference of squares. Factoring the difference of squares. Okay, so I'm just going to scroll up to some notes that I had done prior to this, and I know they're not in your packet, but we'll make it work. Factoring the difference of two squares. Always ask this before you factor anything. Exactly what I just said. Is there a GCF? If so, factor that out first. If a polynomial cannot be factored, remember it is said to be prime. I would write this down. The steps to factoring the difference of two squares. The first question you're going to ask yourself is the first term a perfect square? Is the second term a perfect square? And is there a subtraction sign between the two terms? So the only way it could be the difference of two squares, let's catch on a hint here, the word difference meaning subtraction, is there are two terms, they are both perfect squares, which means when you factor them, they factor into two identical equal factors, and there is a minus sign. Okay, so again, to factor the difference of two squares, you ask yourself, you always say, is there a GCF? If there is, you take that out. Is the first term a perfect square? Is the second term a perfect square? And is there a subtraction sign between the two terms? Are you with me? Okay, let's take a look at a problem. So if we want to factor, the pattern here is a squared minus b squared. A squared minus b squared. A squared is a perfect square. It factors as a times a. B squared is a perfect square. It factors as b times b. And there is a subtraction sign between them. This is the pattern. When you factor a squared minus b squared, it will factor into a plus b times a minus b. And if you remember back in 8.4, when we looked at the FOIL method, and we realized that sometimes when it was x plus 7, and then the other parentheses was x minus 7, that middle term canceled out. This is the reason why. So let's go ahead and take our first problem here, our first example, and let's factor the difference of two squares in the problem n squared minus 64. Question number 1, is there a GCF? No. Question number 2, is n squared a perfect square? Yes, it is. It factors to n times n. Is 64 a perfect square? Yes, it factors to 8 times 8. Is there a subtraction sign between them? Yes, there is. So your answer is going to be n plus 8 times n minus 8. And if you were to FOIL that real quickly, you would see you would get n squared minus 8n plus 8n. Again, that middle term cancels out, minus 64. One more time. If you were to check your work by FOIL, you're going to get n squared minus 8n plus 8n minus 64, or n squared minus 64. Okay, that's how you check your work. Right here, n plus 8, n minus 8 is your solution. So let's try one. Okay, let's try this one right here. Let's try x squared minus 1. X squared minus 1. All right, is x squared a perfect square? Yes or no? Is 1 a perfect square? Yes, it is. 1 is a perfect square. Is there a subtraction sign between it? Okay, then go ahead and factor it. So why don't you guys just go ahead and factor all of them? Sorry about that. So remember, the qualifications are the first term and second term, or we could say both terms are perfect squares, and they have a subtraction sign between it. If not, then it most likely cannot be factored unless there was a GCF. So let's look at our first one here. Our first one, x squared minus 1. Who can tell me what does it break down to? Right here, Justin.
X plus 1 times x squared.
Good job. How about a squared minus 16? What would that be? Thank you, in the back. A plus 4 times a minus 4. A great job. R squared minus 121. Who would like it? Thank you. Right here.
R plus 11, R minus 11.
Good. And the last one, j squared plus 36. Anybody want to take a venture on that one? Yes. Okay, that's a good try, but if you were to FOIL that, you would have gotten j squared plus 12j plus 36. Yes. Yes. He already said that. J plus 6, J plus 6. John?
J minus 6, J minus 6.
That would be j squared minus 12j plus 36. Yes. Thank you. It's prime. Why is it prime, Mrs. Urso? Well, it's perfect square with an addition sign. The difference of two squares, does it have an addition sign? No, it's called the difference of two squares for that reason. Okay, so remember that. All right, let's go ahead and we'll go back to the notes that you guys have in front of you. Excuse me if you're watching online. Just want to get to the right place. So here we go. We did n squared minus 64. Let's do example B. 4m squared minus 81n squared. 4m squared. We're just trying to find a place to do it, that's all. Okay. First thing you have to ask yourself is there a perfect square? Do 4 and 81 have anything in common? Yes or no?
No.
Are you sure? Right, but do they have a factor in common? Okay. Is 4m squared a perfect square? What would it break down to? And how about 81n squared? Breaks down to? And 9n. So that would factor as 2m plus 9n times 2m minus 9n. Somebody foils that real quickly. You should get back 4m squared minus 81n squared. Yes? Okay. Question. All right, let's try. Yes. Two m times 2m is 4m squared, honey. You would get a negative 18mn, and then you would get a positive 18mn, which cancels, and then a negative 81n squared. Okay? All right, let's go ahead and try this one right here. Let's try to do number 4. 36x squared minus 100y squared. I'm just trying to find a spot so that I can write. Tell me which one I picked. 36 what?
36x squared minus 100.
Okay, first question. Is there a GCF? I believe there is.
Yeah.
What is it? Bigger than 2. How about 4?
4.
So this would be 4 times 9x squared minus 25y squared. Yes? Okay, is 9x squared a perfect square? Yes, it is. 3x and 3x. Is 25y squared a perfect square?
Yes.
5y and 5y. So this would become 4 times 3x plus 5y times 3x minus 5y. Final answer. Yes. If it's not a perfect square, then maybe that's as far as you could factor it. So if it was a plus sign here, then maybe your answer would have been 4 times 9x squared minus plus 25y squared. Yes. There's positive and there's minus. There is one negative. Yes.
Can you do it in simple, please?
Okay, I'm doing things in a certain order, so if you could hold on, that would be awesome. I have certain things that I need to cover, okay? But I'll be happy to do it for you, whether at the end or before we leave here today. All right, let's go back here for a second. Okay, let's look at this problem right here. So if I were you, I would write this one down. This is a really good problem. This is a really good problem. This is called applying a factoring technique more than one time. More than one time. Okay, this is not in your notes. I'm not sure why this page did not copy. Okay, so here we go. 2x squared minus, was it 32 or 32x, the original problem? 32. Okay, so here we go. Is there a GCF? Hey guys, is there a GCF? What is it? Okay, so we're going to take the 2 out. And so now it becomes 2 times x squared minus 16. Now, can what is left in parentheses be factored again? And then I've written, does it fit a pattern? Well, let's look at x squared minus 16. Hey guys, this is how you have to start thinking. When you see 2 terms in parentheses with a subtraction sign, the very first thing, if you look on your flow chart, that you should ask yourself is it the difference of 2 squares? Is x squared a perfect square? Yes. Is 16 a perfect square?
Yes.
Yes, so this would factor as 2 times x plus 4 times x minus 4. And again, this material is not on Friday's test. However, I did want to finish the whole chapter today just to keep continuity going. Are you with me? Okay, I need to move on to the second part of the lesson. Don't forget what your question was, and I will answer it in private. It might not make it on the video. Okay, one more that I want you to look at would be 4m squared minus 81n squared. I think we did this problem, yes? Yes?
Yes.
Okay, then we're good. All right, the second thing I want to talk to you about today, why don't you guys go ahead and pull your flow charts out real quickly. And I want you to look at them. For those of you that are following online, if you have my notes, please take them out at this time. So, the first thing you want to make sure is that when you factor something, it's in standard form. That's why that one problem that Joseph asked, I think it was number 12 in the homework, that's why we went ahead and I rewrote it. Okay? Then you need to see, is there a GCF? If there is, take it out. Now, if you have a binomial, is it the difference of 2 squares? If it is, then factor it. If it's not the difference of 2 squares, and you may want to put there because there's an addition sign, then it can't be factored. The middle one is it a trinomial? Is it a perfect square trinomial? We're going to talk about that now. Is there a coefficient other than 1? And these all can be x factored. And then the last one is it a polynomial with 4 terms or more? Then we're going to factor it by grouping. So I just want to add a little bit to the notes that we have. So let's look at perfect square trinomials. So if you follow along in your set of notes, the first special technique was in 8-7 was the difference of squares. If you guys turn the page, the next technique is perfect square trinomials. A perfect square trinomial from today and forevermore will be known as a PST or PST. All perfect square trinomials factor into 2 equal factors. The first term is a perfect square, the third term is a perfect square, and the middle term is 2 times or negative 2 times the square root of the first times the square root of the third. Okay, I will go on record as saying that this is extremely important. So that should have been a major hint for everyone. Okay? A perfect square trinomial. How do you know? The first term is a perfect square, third term is a perfect square, middle term is 2 or negative 2 times the square root of the first times the square root of the third. So if we want to go ahead and we want to factor x squared plus 10x plus 25, and the directions read something like this. Is this a perfect square trinomial? And you had to answer yes or no. And then the second part of the directions, whether it is or it's not, they want you to factor it. Well, x squared plus 10x plus 25. Let's see if it fits the 3 criteria. Is the first term x squared a perfect square? Yes, it breaks down to x times x. Is the third term 25 a perfect square? Yes, it breaks down to 5 times 5. Is the middle term 2 times or negative 2 times the square root of x squared? The square root of x squared would be x. And times the square root of the third, the square root of 25 would be 5. So when you multiply 2 times x times 5, do you get the middle term of 10x? Yes, you do. If so, then it is a perfect square trinomial. And how do you get your answer? I'm so glad you asked. So everybody pay attention and look up here. Now guys, obviously this can be x factored. It can be x factored, but I want to go on record as saying that when you see the pattern, you could skip that and go right away over here. So let's just take a look. The first term, x squared, breaks down to x and x. The third term breaks down to 5 and 5, and there are 2 addition signs. So it would be x plus 5 times x plus 5. Most Algebra 2 teachers want to see it as x plus 5 quantity squared. If you see this problem or something similar to that on this week's test, basically all you're going to go ahead and do is x factor it. What multiplies to 25 and adds to 10? 5 and 5. Are you with me? Yes? Let's try another one. Is this trinomial a perfect square trinomial? X squared plus 16x plus 64. Is it a perfect square trinomial? Is the first term a perfect square?
Yes.
Is the third term a perfect square?
Yes.
Is the middle term 2 times the square root of the first times the square root of the third?
Yes.
Good. Who can factor it for me? What would my answer be? Let's go. Anybody? You know? Tell me. X plus 8 quantity squared. Okay? How about x squared minus 10x plus 25? Well, let's take a look at it. Is the first term a perfect square?
Yes.
Is the third term a perfect square?
Yes.
Is the middle term 2 times, or in some cases, negative 2 times the square root of the first times the square root of the third? Yes. So who could factor that for me? But be careful because there's a minus sign here. Yes. X minus 5 quantity squared is awesome. So what do you know about a perfect square trinomial? Glad you asked. A perfect square trinomial always factors into two equal factors. Okay? The first term is a perfect square, the third term is a perfect square, and the middle term is 2 times or negative 2 times the square root of the first times the square root of the third. All right? So let's go ahead and try a couple of problems from your notes. So here we go. Perfect square trinomial. Let's go ahead and look at number 3. Is it a perfect square trinomial? I need a yes or a no. And then if it is, I need you to factor it. Is everyone with me? Hello? Thank you. Appreciate it. We are almost done. We're going to wrap this up here in a minute. That flow chart can really save your lives, guys, so make sure you use it. Okay, p squared plus 8p plus 64. Who's got an answer for me? Is it a perfect square trinomial? Who's going to be bold? Raise your hand. Come on. Anybody? It is? Why? Okay. And that would have given you a middle term of 16p. So is it a perfect square trinomial? No. Good save. Good job. Nice way to think through the problem. I appreciate that. Are y'all with me? Yes? Okay. Just going to check one more thing here. Yes, question. Yeah, did you write down what I told you to write down? Okay, so p squared. So let's look at it over here. P squared plus 8p plus 64. Is the first term a perfect square? Is the third term a perfect square? Is the middle term 2 times the square root of the first times the square root of the third? 2 times p is 2p. 2p times 8 is 16p. What's my middle term? 8p. It's the same thing that he just asked over here that he just said. So no, it cannot be a perfect square trinomial. You're welcome. All right, this concludes our lesson for today. Thank you for listening to us. This does wind up Chapter 8. However, we are going to spend the rest of this week reviewing for our test on Friday, and then we're going to pick up more review next Monday and Tuesday for a final test next Wednesday over the whole chapter. Hope you guys have a wonderful day.